let me show you how I can prove that the sine of 2x is equal to 2 times the sine of x times cosine of x. Okay, so sine of 2x, that would be equal to the sine of, well, 2x is the same as x plus x, and then we'll use the sum formula for sine, so sine of the first cosine of the second plus cosine of the first times sine of the second, and so that establishes that there's two of those, sine x times cosine of x. Okay, we can do this a similar kind of proof for this other one, for the formulas for cosine. So let me just show you that. So we want to show that cosine of 2x is equal to cosine squared x plus sine squared x. Let me just show you how we go about that. We've got cosine of x plus x, and then we'll use our sum formula for cosine, so it would be cosine of the first times cosine of the second minus sine of the first times sine of the second. So that's the top, let's see, can I scoot? Okay, so that's this one here, and then we can replace, if we wanted to replace this, we could replace that with 1 minus sine squared. So then minus sine squared of x, and then that would give us 1 minus 2 sine squared of x. And then the other one, so we just showed that one, and then this other one, 2 cosine squared x minus x, you get that if you just replace your sine squared with the trig identity, or the Pythagorean identity. Okay, so we've established those. The tangent one I'm not going to show. It doesn't show up very often. I just want you to have it in your notes. Okay, so let me show you how we can actually use this. So if I have cosine of negative 3/4, cosine of x is equal to negative 3/4, I would need to find sine of 2x. Okay, so I'm going to draw a picture. I'm in quadrant 2. All right, and cosine of x is equal to negative 3/4, and remember that cosine is the adjacent over the hypotenuse. And so we would have, here's our little angle, there's x, and let's see, this is negative 3, the adjacent, and the hypotenuse is 4. And then we use Pythagorean theorem, and we figure out that y is equal to square root of 7. So then that would give us that the sine of x, which is the opposite over the hypotenuse, would be, let's see, opposite, we just found that the opposite here would be square root of 7, and the hypotenuse is 4. Okay, but now what we want to do is use all of that work to actually find the sine of 2x. Okay, the double angle formula for sine says that sine of 2x is equal to 2 times sine x cosine x. So it would be 2 times sine x. We just found that sine x is equal to square root of 4, or square root of 7 over 4. Okay, good. And then we were given the cosine. Okay, so we know that one is negative 3 over 4, and then we just simplify this up. So let's see, it would be negative 3 root 7 all over 8. All right, so that's done, and that's using our double angle there for the sine. All right, let's see, cosine of 4x. We want to rewrite that and eventually have an expression that only has sine in it. Okay, so I'm going to take, let's see, one of the cosine. I'm going to use, okay, I'm going to use since my goal is to find an expression that only has sine, the only good contender in my eyes is this middle double angle formula for cosine, because the other ones have a cosine in there. So let's use that one. So it would be 1 minus 2 times the sine of our half of our angle. So that half of 4x would be 2x. Okay, I'm just going to make this a tiny bit easier for me to see. So sine squared x, or sine squared of 2x would be, we could write it like that. And now I'm going to use my double angle formula for sine. And the sine double angle goes like this. 2 times sine x cosine x. And that's still all being squared. So let's see, I'm going to go ahead and apply my power. So I would have 4 times sine squared x times cosine squared of x. And now my goal, keeping my goal in mind, I don't want to have any cosines. So I want, right, I just want sines. So I'm going to replace that cosine using the Pythagorean identity. So 1 minus, let's go ahead and just multiply 2 times 4. So it would be 8 sine squared of x. And then cosine squared of x, I'm going to replace that with 1 minus sine squared of x. And now the only thing I need to do is just distribute my negative 8 sine squared of x to both those terms in the parenthesis. So it would be 1 minus 8 sine squared of x when it multiplies times 1. So that's this first one. And now we have to distribute it to the negative, times negative is positive, 8. And then we have sine squared x times sine squared x. So that would be sine to the 4th x. Okay, and it's kind of messy, but I did what I was asked. I am done. Okay, the next one I'm going to verify is this formula which lowers the power. So we've got sine squared x is supposed to be equal to 1 minus cosine of 2x all over 2. So I'm just going to show you that it really does, that it does work. Okay, so I'm going to start with 1 minus cosine of 2x all over 2. I'm going to use my double angle formula for cosine, and I'm going to use the one that says cosine of 2x is equal to cosine squared of x minus sine squared of x. Okay, and then that was all over 2, and then let's go ahead and distribute our negative. So then we would get 1 minus cosine squared of x, and then plus sine squared of x all over 2. Oh, 1 minus cosine squared, there's a Pythagorean identity right there. So let's go ahead and replace that with sine squared of x. And then we still have that original sine squared of x in our numerator, so that gives us 2 sine squared of x in the numerator. And then those will just simplify, and we have shown that that formula really does hold true. All right, I'm going to do one more example in this. All right, let's go ahead and use this. So I have sine to the 4th of x, and my mission is to write it just in terms of cosine and only have the highest power be 1. Okay, so here we go. Sine to the 4th x, that's the same thing as taking sine squared of x and squaring it. Then I'm going to replace sine squared of x, lower that power down. That's the same thing as 1 minus cosine of 2x all over 2. Okay, and then we still were squaring that whole quantity, and we'll multiply that out. You've got to FOIL the top, and so we end up getting 1 minus 2 cosine of 2x plus cosine squared of 2x, all in the numerator. Okay, I'm just going to make this a tiny bit easier. I'm going to so I'll take my 1, just to divide everything separately by 4, minus, let's see, 2 cosine of 2x over 4. That would simplify to cosine of 2x over 2. And then here, instead of taking cosine squared of 2x and dividing it by 4, I'm just going to multiply it by 1/4. Okay, and now we can lower our power. Okay, so I've got 1/4 minus this cosine of 2x, I'll just write that as 1/2. times cosine of 2x, and then I've got plus 1/4, and cosine squared of 2x, that simplifies to 1 plus cosine of the double angle, so it'd be 4x all over 2. Okay, but let's write that separately. With 2, we're going to divide each of those separately, just makes it a tiny bit easier. Let's see. Okay, there. Now, I'm going to distribute my 1/4 to the 1/2 and also to that cosine of 4x over 2. So now I have, just copying the first stuff, 1/4 minus 1/2 cosine of 2x, okay, plus 1/4 times 1/2 is 1/8, and then plus, let's see, 1/4, let's see, I have cosine of 4x all over 2, but the 1/4 is getting multiplied by that, so that would be 1/8. And now I have to just simply add my fractions, and I am going to be done here in a minute. Okay, so a 1/4 plus an 1/8, that is 3/8 minus 1/2 cosine of 2x plus 1/8 cosine of 4x. We have an expression. It only has cosines, and the highest power is 1. Mission accomplished.